Hello everyone, this is Mohammed Zishan from ETH Montreal. In this presentation, we introduce CLIP-AUTT, a test-time personalization with action unit prompting for fine-grained video emotion recognition. The goal is to adapt the model to certain emotions expressed by unseen individual during test time. Right, so the challenge is that in fine-grained states such as pain, stress, and ambivalence are difficult to recognize because their cues are weak, brief, and subject-specific. So existing clip-based method approaches mainly rely on static class prompts that provide limited information, while LLM-generated prompt can be noisy and computationally expensive. So these fixes or inefficient prompt cannot be adopted to the expression style of an unseen individual during inference. Right. So a class prompt describes only the overall emotions, such as a person with pain or a person with an expression of pain or stress. While LLM description can be richer, but they are noisy and computationally expensive. So instead, we use action units which describe a localized facial muscle activations and provide structure interpretable prompt for certain emotion recognition. So our method has two stages, CLIP-AU and CLIP-AUTT. In the first stage of CLIP-AU, it learned generic relationship between the emotion class and combination of action unit across labeled source subjects. In the second stage, which is CLIP-AUTT, which is then used to adopt to unseen individual emotion that uses prediction from entropy to select the most informative temporal window and personalizes a small set of AU prompt embeddings to the unseen target subject at test time. Alright, so action unit describes specific facial movements. For example, AU6 is for cheek raiser, AU12 is lip corner puller, making them interpretable, and fine-grained emotion emerge from the combination of these action units rather than pronounced facial display. So AU prompt provides structure, localized cues without relying on noisy LLM description. So the first stage is training of CLIP-AU using a source label data. We use image and text encoder which remain frozen. Video frames are encoding using a temporal module containing a lightweight 1D convolution, GLU, and a temporal pooling layer. In parallel, the AU text embeddings are refined using a small adapter. Similarity between the video representation and AU embeddings form an activation vector. A lightweight classifier mapped these to an emotion category using emotion labels but without needing AU annotations. So next we train CLIP-AUTT method for test time personalization. So first we identify the most expressive segment of an unlabeled target video. So for that we divide the video into overlapping windows and select the window with the lowest prediction entropy. Using this window we tune only the AU prompt embeddings while keeping the entire CLIP-AU model frozen. This personalizes the AU semantics to the target subject's facial pattern. The adopted prompt are used for prediction and then reset before processing the next video. Next, we evaluate the method on three fine-grained video dataset: BioWeight for pain, stress ID for stress, and BAW for ambivalence and hesitation. CLIP-AU is compared with clip-based fine-tuned methods for FER, while CLIP-AUTT is compared with the test time adaptation method. Both proposed approaches achieve the best overall result across three datasets. So we compare with the strongest test time baseline. CLIP-AUTT improved VAR by 5.4 point on BioWeight, 4.9 point on stress ID, and 1.9 on BAR. It also remained efficient using only 0.09 million trainable parameters and processing over 26 videos per second. Next, qualitative result. The qualitative result explain these gains. As you can see, CLIP-AU capture generic muscle activation patterns, while CLIP-AUTT adopt them to each subject and show the stronger agreement with the action unit estimates from open face. The minimum entropy window also contain the cleanest and most temporally consistent expression cues, providing a reliable signal for personalization. Right, so the main takeaway is that the method is interpretable, subject aware, efficient, and designed for video. AU prompts connect prediction to recognize facial movement. Test time prompt tuning adopt one scene individual without retraining the full model, while entropy guided window selection avoids weak and ambiguous segments. Together, these components enable practical fine grained personalization. So to conclude things up, CLIP-AU learn fine-grained temporal AU pattern and CLIP-AUTT personalizes these patterns once in subject at test time. And thank you for watching. Please use our QR code to access the paper and additional results. Thank you.